All right, let's talk about something that feels like it's straight out of a movie: quantum computing. It's this incredible technology that promises to literally change everything, but, and here's the catch, it's built on a science so weird, even the people who discovered it were completely stumped. So what is the real story here? What's the promise? And what's the paradox?
You know, to really get this, we have to start with how fundamentally bizarre the quantum world is. Niels Bohr, one of the fathers of this field, he put it perfectly. The takeaway here is that if you're not confused, you're not paying attention. Even the geniuses who came up with this stuff were baffled. Quantum mechanics just doesn't play by rules our brains can easily grasp.
And that brings us to the big central question, doesn't it? If the science itself is so mind-bendingly strange, how in the world can we even begin to build a computer out of it? It's a fantastic question, and, well, the answer really begins with a whole new way of thinking.
To answer that question, we got to grasp the core idea behind this whole revolution. See, this isn't just about making a faster computer. No, it's about making a different kind of computer. One that, you could say, thinks a bit more like the universe itself.
This idea has been kicking around for a while. Back in the early 80s, the physicist Richard Feynman had this big aha moment. He realized that trying to simulate a quantum system, like a complex molecule, on a regular computer is basically a fool's errand. The complexity is just off the charts. His radical insight was, wait a minute, to solve a quantum problem, what if you need a quantum computer?
And that really is the heart of it. Think about our biggest challenges. Designing new medicines, creating new materials. A lot of these are fundamentally quantum problems. Our normal computers, they struggle because they're speaking the wrong language. The big idea is that if we want to solve problems written in the universe's native tongue, we need a machine that can finally speak it.
Okay, so what's the payoff? What do we actually get by speaking the language of the universe? This is where things get really exciting. This is the quantum advantage. The special powers that make these machines, well, unbelievably powerful.
So the power really starts right here, with the basic building block. Your phone, your laptop, they use bits. And a bit is simple. It's like a light switch. It's either on, a 1, or it's off, a 0. But a quantum bit, a qubit, is way weirder. It's more like a dimmer switch. Because of this wild property called superposition, it can be a 1, a 0, or it can be both at the exact same time.
Now, that ability to be in multiple states at once, it's a total game changer. Imagine cracking a simple 4-digit PIN. A normal computer has to do it the boring way. Check 0000, nope. Then 0001, nope, 1 by 1. A quantum computer, though, by using superposition, it can basically check all 10,000 possibilities in a single shot. That's not just faster, that's a whole different league.
And then there's the second quantum superpower, entanglement. This is what Einstein famously called spooky action at a distance. It's where two qubits become so deeply connected that if you measure one, you instantly know the state of the other, even if it's across the galaxy. It's like they have this psychic link, allowing the computer to process information as a single, connected whole.
So just how powerful is this? I mean, what does this combo of superposition and entanglement get you? Well, get this. With just 300 perfectly entangled qubits, you could represent more possible values than there are particles in the entire known universe. It's a computational space so huge, our minds can't even really map it.
Okay. So with that kind of insane power, you'd think quantum computers would be running the world by now, right? But you probably guessed it, there's a catch. And it's a really, really big one.
This is the other side of that paradox we talked about. If these things are so powerful in theory, why aren't they everywhere? What's the holdup in the real world?
Well, the hurdles are huge. The very quantum weirdness that makes qubits so powerful also makes them incredibly delicate. They're like little divas. The tiniest vibration, a little bit of heat, any noise from the outside world, and poof, the whole calculation collapses. That's why they have to be kept in these crazy, super cold environments, colder than deep space. This fragility also means they make a lot of errors, and figuring out how to fix those errors is a massive challenge in itself. And maybe weirdest of all, they don't always give you a single right answer. They give you probabilities. And because of all those challenges, quantum computers today aren't like a Swiss Army knife. They're more like a surgeon's scalpel, highly specialized. You can see here, different machines are built to do very different things. Google's Sycamore is focused on things like cryptography, while Rigetti's Aspen is built for chemistry simulations. Some machines are even built for just one job, figuring out how to get better at correcting errors. So no, they aren't going to replace your laptop anytime soon.
But, and this is a big but, even with all these limitations, these machines are already starting to probe the very fabric of reality. They're doing things that, until now, we could only dream of. And here is one of the most mind-blowing examples. In 2022, scientists used Google's quantum processor to simulate a wormhole. Now hold on, let's be super clear. They didn't punch a hole in space-time in a lab in California. So, what did they actually do? What they did was simulate how information would behave if it passed through a wormhole. And why that's so cool is that it's a test of an idea that could finally connect Einstein's theory of gravity with quantum mechanics. These are the two great pillars of modern physics, and famously, they don't get along. They don't play well together. So this experiment used a quantum computer to build a tiny bridge between them to see if the math actually holds up. They were using it to ask fundamental questions about how reality itself works.
And that brings us to the final and maybe the most profound idea of all. What does this technology really mean for how we see the world, for how we understand complexity itself? Take a look at this number, 2 to the power of 266. It's just a number on a screen. It doesn't really mean anything to us. This number represents the number of possible outcomes if you just flip a coin 266 times. So how big is it really?
Well, to even try to count that high, it would take you 10 billion universes running for 100 times the current age of our own universe just to get through all the possibilities. The point is, the universe is, by its very nature, incomprehensibly complex, even in something as simple as flipping a coin.
This unimaginable complexity leads to a very human problem, which is captured perfectly in this old metaphor. We're like a person who lost their keys in the dark, but they only look for them under the streetlight. Why? Well, not because that's where the keys are, but because that's where the light is. We naturally stick to the simple, manageable problems because that's what our brains and our classic computers are good at.
So this is the real takeaway. The myth is that quantum computers are this magic wand that's going to solve all of that complexity for us. But the reality is actually way more interesting. They don't get rid of the darkness. What they do is give us a brand new, powerful streetlight. They let us start looking for answers in places that were completely dark to us before, and to tackle a whole new kind of complex, interconnected problem that's always been out of our reach.
And that leaves us with one last question to chew on. With every new technology we build, from the first calculators to these incredible quantum machines, are we actually getting closer to understanding the universe's true infinite complexity? Or are we just getting better and better at building tools that allow us to ask more manageable questions? It's a thought that puts all of our incredible progress in a fascinating new light.